Yes, friends. So we are continuing with question number 6th and part A. So what are the favorable cases in this case? Only no head and one head. No head means only tail. This is one possibility, and one head means there are two possibilities. Total 4 cases were there. Well, a coin is having outcomes 2 in case of one throwing. Two outcomes are there. If it is tossed twice or 2 coins are tossed together, that means 2 raised power 2 means total 4 cases were there. What are total 4 cases? Head, tail, head, and tail. These 4 cases are there. Out of that, one head and no head. This is the first. At most 1. At most 1 means maximum 1. Lesser than 1 is also possible. So no head is also possible. Means 0 head. 0 head and 1 head. These 2 cases will be taken in this case. 0 head means tail only. 1 head means HT and TH. Head, tail, head. That is the point. So 3 cases are there. Total number of favorable cases in this case is 3. And total number, how many total cases are there? Total 4, because in this case total favorable cases are there. So total number of cases is equal to 4. Why 4? H, HT, TH and TT is the 4 cases in the sample space. Sample space I just expressed. HH, HT, TH and TT. Tail. Okay. These are 4 possibilities. Total outcomes are 4. Total number of cases is 4. Favorable cases in this case are 3. So 3 upon 4 is the probability of getting at most 1 head. Hence, probability of at most 1 head is equal to 3 upon 4. Because 3 is the favorable cases. 3 number of favorable cases is 3. Total number of cases is 4. So this is the answer. First part is answered here. Then B part. In case of B part, I'll just clean this undoubtedly. I have to clean this first. Let me. Okay. No problem. After that. Okay. In the second case, at most 2 heads, maximum 2 heads. It means the cases, favorable cases in the second case, in B part, favorable cases are, which are the favorable cases? All the 4. Why? That means, let me take how many cases are there. That is no head plus 1 head plus 2 heads. Why? Because at most 2 heads, maximum 2 heads. Maximum less than 2 are also possible. Less than 2 means no head, 0 head, 1 head and 2 heads. These are all possibilities. So these cases are, let me write down them. No head means tail. 1 head means head, tail, head and head, 2 heads. These are all 4 cases. So in this case, probability is 1 because number of favorable cases are also 4. Total number of cases is also 4. Total number of cases and the number of, let me take NE. NE means the number of events in case of favorable events is 4. Total 4. Total number of cases or total number of cases in the denominator is also 4. Therefore, probability of at most 2 heads. At most 2 heads is equal to 4 upon 4. That means 1. 4 on the 4. This is the answer. Okay. So question number 6 complete. Question number 6 or 6th question is completed. Okay. Now let me take question number 7. What does question number 7 say? Let me talk about that. First, let me clean this. Okay. Now question number 7. Question 7 says, let me write here, given, what is given to us in question number 7? Question number 7, what does it say? A positive integer is selected. Alright, a positive integer is selected. Now, at random, n is divided by 7. Okay. A positive integer is selected and is divided by 7. Then what is the probability that the remainder is 1? A part and B part is not 1. Remainder is 1. Now let me first write it down. What is given to us? A positive integer. A positive integer is selected. A positive integer is selected. Right? Positive integer selected at random. No problem. At random. Now try to understand this question. And divided by, and is divided by 7. And divided by 7. This is the question. Now to find, there are two parts of this question. First part is, what is the probability? What is the probability? Okay, what is the probability that the remainder, try to understand what the remainder, quotient and divisor, okay, and dividend. So I'll just talk about that. Okay, what is the probability that the remainder is part A, the remainder is 1 and B part is not 1. Very important question. When remainder is 1, if I divide a number by 7, then either remainder is 0 because it's completely divided by 7. Suppose 14 is there. Okay, so 14 divided by 7 is 7 to the 14. 2 is the quotient, but remainder is 0 because 14 minus 14 is 0. Remainder is 0. 0 means difference of the the dividend. We have we are dividing, 7 is divisor here, or dividend is 14. Sorry, in this case any that integer is not given to us. Any integer, suppose this is 14, so 14 of 7 divided by 7, 1 is quotient, is divided by 1 time, but remainder is 7 minus 7, 0. Similarly 14 minus 14, 0. If 14 divided by 7, that means 0 is the remainder. 0 can be the remainder in this case. 1 can be remainder also. If suppose 8 is divided by 7, 7 means 7, 8 minus 7 is 1 remainder. 9 divided by 7 means 2 remainder. 10 divided by 7, 3 remainder. So up to 6 can be the remainder, right? Or if it is, 6 can be the remainder. Suppose if there is a number 13 divided by 7, 7 1 is 7, 6 is the remainder. Maximum 6 remainder, lesser or least or minimum is 0. I mean 0 is the quotient, sorry, remainder. 0 to 6, there are 7 remainders. Let me write here. So solution here, try to understand what the remainder means. Remainder is quotient, remainder, divisor, dividend. These are the 4 parts of a number. Suppose 14 is divided by 7. 7 is known as divisor. This is known as dividend. Right? Dividend, sorry. Dividend. This 14 dividend, divisor is 7. We are dividing 14 by, suppose 14 is an integer which is being selected at random, and then divide by 7. So 7, if I divide 14 by 7, 0 is the remainder. Why? Because 2, 7, 2 is 14, so 2 is the quotient. Because 7 into 2, so 2 is the quotient here, that is known as quotient, that you know about. So 2 times it is divided, 7 2 is 14, so 2 is the quotient. But the remainder then 14 minus 14, because 7 2 is 14, 14 minus 14 0, 0 is the remainder. So remainder here, 0 is the remainder. What is the remainder here? So remainder after dividing that number by 7, whatever the difference comes out to be of the result which is obtained by dividing quotient multiplied that divisor, whatever the number obtained, and that is being subtracted from the dividend, the numerator. That will give us the remainder, the difference. The remainder is 0 in this case. And if it is 13, then 6. 6 is the remainder. So maximum remainder is 6. 0 to 6. 0, 1, 2, 3, 4, 5, 6. There are 7 remainders in this case. The number of remainders possible. So total, let me take total number of cases of remainders. Total of remainders. How many remainders are there? 0, 1, 2, 3, 4, 5 and 6. Up to 6 may be the remainders. 0 to 6 are the 7 remainders. 0, 1, how many cases are there? 1, 2 total cases are these. Now if 1 is remainder, 1 is only 1. So favorable cases is 1. Now in this case favorable cases is 1 because 1 is the remainder. You have to find out what is the remainder of 1. Let me now write down there. In this case, now A part. Total number of cases we have just talked about. These are the remainders up to 0 to 6. Now, number of favorable cases are what? In the first case, when remainder is 1, there is only one remainder, 1. One case is there. So favorable cases is only 1. Okay, so I mean number of events, number of favorable cases number of favorable cases in our event is only 1. This is 1 only. One outcome. This is 1. That means 1. Total are 7. 1 to 0 to 6, 7. And total, let me take total events for total cases is 7. Therefore, probability of remainder 1. Probability of remainder 1 is equal to 1 upon 7. Why 1? Because number of favorable cases is only 1. 1 is only one case, one remainder. And one remainder is there, so one case. Total number of cases are, total remainders left, remainder are 0 to 6, that means 7. Total cases are 7. One favorable case is 1. 1.7 is the answer. So this is the answer of part 1, part A. So part A is the answer. Let me talk about part B. Now B part says not one remainder. It means other remainders may be there, 0 may be the remainder, not 1. So left 1, how many cases are left? 6. 0, 2, 3, 4, 5, 6. So favorable cases are 6. 6 upon 7. Or we could just subtract this 1.7 from 1. Leftover value is 6 upon 7. From here also, favorable cases are 6 leftover because 1 is deleted or 1 is just taken out, and remaining favorable cases are remaining, or remaining cases are favorable cases. In case of second case, not 1. Remainder is not 1. It means remainder can be 0, can be 2, can be 3, can be 4, can be 5, can be 6. All the favorable cases are there. So in case this favorable cases are favorable cases in this case are 0, 2, 3, 4, 5 and 6. 6 cases are there, 3 and 3. So number of, or we can say NE, let me write NE. The number of favorable cases is 6. 3 plus 3, 6. And total number of cases, total number of cases. How many cases were there? 7, 0 to 6. So 7 it was. Therefore, probability of remainder not 1. Probability of remainder not equal to 1 is equal to 6 upon 7. What is the probability? Number of favorable cases divided total number of cases. Favorable cases are 6 here in this case. 6 upon 7 is the answer. This is B part of this question. Okay, so question number 7 is finally completed. Okay, let us take now question number 8. This is question number 7. We have completed 2 parts were there of this question. If a remainder of if an integer is selected into positive integers are 1 to infinity, any number can be selected, and that number is divided by 7. When we divide any number by 7, the remainders are either 0 if it is completely divisible, that number is a multiple of 7, suppose. Any number is, that integer is a multiple of 7, then 0 is the remainder. If it is more than 7, it may be more than 7 as 1. So for example, 8 is divided by 7 means 1 remainder. 9 divided by 7, 2 remainder, as I have just told you. Let us take next question. Question number 8. So we have to just understand what the wording of the questions. So wordings, if are understood, we can solve the question. Simple. That is, in case of everything, whatever you have understood the question, then you can solve it, or you know the basics of this. Basics I have already clarified. Now 1 to question number 3, symbols were used, terms were there, definitions of probability are defined. Okay, who were the contributors that I have also talked about. All the things after this basics are clear, then questions are easily solved. So probability definition, probability how to calculate probability of an event is equal to number of favorable cases divided by total number of equally likely cases. In this case, we are taking always equally likely cases. Only then probability can be calculated. We take question number 8 now. Question number 8, what is given to us? What is given to us? Question number 8. Let me talk about now. Question number 8 says, this is 8. A dice is thrown. What is the probability that the number shown on the dice is not divided by 3? Not divided by 3. This we have, this kind of question we have done already. A dice is thrown. What is given to us? A dice is thrown. How many times? A dice is thrown. Only a dice is thrown. Alright, then find here. What is the probability? Then what is the probability? What is the probability of, okay, probability that the number shown on the dice is not divided by 3? Simple question. So this I have just talked about, that we can do it in 2 ways. What the probability that the number shown on the dice, number shown on the dice is not divisible by 3. Is not divisible by 3. That is the probability bet 100. So that number shown by on the dice is not divisible by 3. So which are the numbers which are not divisible by 3? Only 3 and 6 are divisible by 3. Other 4, the total cases are 6. 1 to 6. Because dice is numbered as 1 to 6. 1, 2, 3, 4, 5, 6. There are 6 faces of this, 6 sides. So this is a hexagon type. Okay, so 6-sided figure, not hexagon. We can say that this is a keyboard shape. Keyboardless cube type, not keyboard but cube type. Cube type means it is having numbers, maybe keyboardless shape also, but it is having 6 faces of this. 6 faces are numbered as 1 to 6. Then that is the dice here. So in dice, which numbers are divided by 3? 3 and 6 only. Which are the numbers which are not divided by 3? 1, 2, 4, 5. 1, 2, 4 and 5. Means 4 numbers left over are not divided by 3. We can do this in 2 ways. Either 4 upon 6, this is 2 by 3. 2 by 3 is the answer, because those numbers are, favorable cases are 4 only. 1, 2, 4 and 5. These 4 numbers are not divided by 3. 3 and 6 are divided by 3. So, or 2 upon 6, we could do 1.3 is the answer, or 2 by 3, sorry, 1.3 is the numbers which are divided by 3. That's the probability of divided by 3, numbers of divided by 3. Probability of the numbers which are divided by 3 is 1.3, because 2 cases are there, 3 and 6, which are divisible by 3. But we have to find out what the probability of the numbers shown on the dice which are not divisible by 3. That we have to calculate. So that can be done in 2 days solution. I just calculated this kind of question in the previous one. Okay. So the total number of favorable cases are total number of total cases are, let me take total cases equilateral cases in this experiment, or random experiment are, what is the sample space here? 1, 2, 3, 4, 5 and 6. This is the total number of 6 cases are there. Okay, because the dice is numbered like this. Now come to the point. What is the total number of favorable cases? So the favorable cases, let me take the favorable cases. The favorable cases is equal to 1, 2, 4 and 5. These 4 are not divisible by 3, completely divisible by 3. They are not multiple of 3. These 4 are there. So number of favorable cases NE is equal to 4, and total number of cases, total number of E, total number in E is how many? 6. Therefore, probability of numbers not divisible by 3, of numbers not divisible by 3 is equal to 4 by 6. That means 2 by 2 to the 4 and 2 3 the 6. So 2 by 3 is the answer. Or we could do in the way, suppose we have to calculate the probability of those numbers which are divisible by 3, and that is 2. Or in other way, the probability of numbers divisible by 3, okay, is equal to let me take probability here. Probability that even of numbers divisible by 3 is equal to favorable cases. Which are those favorable cases? 2 only. So favorable cases divided by total number of cases. This is total number of cases. Total cases or total number of cases. Which are those favorable cases are? Let me first write what are the favorable cases. In this case, 3 and 6 is the 2 numbers which are divisible by 3. Okay. So favorable case, these are favorable cases. Favorable cases are these 2. In case when the numbers divisible by 3. But this is not the question in this case. In this question is that what is the probability of those numbers which are not divisible by 3. If we are calculating numbers divisible by 3, then this will be subtracted from 1. That probability will be then finally calculated. This is the second way. Favorable cases are 3 and 6, and total number of cases that we know about. Total cases, or total number of cases, let me take, is 6, and this is 2, and E is 2 in this case, 2 cases. So therefore probability of divisible by 3 probability of numbers divisible by 3. This we are calculating in this case. That means 2 by 6. 2 by 6 means 1.3. But we have to find out what the probability of numbers not divisible by 3. Therefore, probability of numbers not divisible by 3, not divisible by 3 is equal to 1 minus probability of, let me take probability of numbers divisible by 3, probability of numbers divisible by 3. This is the second type of solving this question, second method of solving this question. This is 1 minus 1.3 was, we just calculate 2 upon 6, okay, of number divided by 3. Now this is the difference to 2 by 3. This is the final answer. 2 by 3 is the probability of those numbers shown on the dice which are not divisible by 3. This is the answer. In this way also we can first calculate the probability of those numbers which are divisible by 3, subtract it from 1. This we have done here, this is 2 by 3. So in both way answer is 2 by 3. Okay, so either way we can solve the question. But that was the easier one. Directly we can show that which are the numbers which are not divisible by 3. They are the 4, 4 upon 6, 4 upon 6 means 2 by 3, and 2 by 3 is the final answer. Okay, so both way we can solve this question. Now question number 9. Before solving that, let me create this. Okay, now question number 9. Let me talk about. Yes guys, now question number 9. Let me now talk about what is given here. Let me first read it and write it down. Question 9 says, when a coin is tossed for 5 times, for 5 times, when a coin is tossed 5 times or for 5 times, or a coin is tossed 5 times, find the probability that it turns up heads exactly 3 times. That is the point here. What is it given? A coin is tossed 5 times. This is 5 times, or for 5 times we can say. You find here, you find probability of, or probability of, okay, that it exactly, find the probability that it turns up heads exactly 3 times. Find out the probability that of, probability turns up heads exactly 3 times. Probability of heads turns up, heads turn up, or turns up, heads turn up. How many times? 3 times. Exactly 3 times. Right? That is the point here. Out of 5 times, okay, the coin is tossed 5 times. That means 5 heads may turn up, 4 heads may turn up, but exactly 3 heads will be turned up. That is the question we have to find out. Okay. So let us say that if a coin is tossed 1 time, solution. Now this solution let me find out. Let me first show you that what is the total number of possibilities. In case one coin is tossed 1 time, there are 2 possibilities, head and tail, 2 possibilities. If it is repeated, suppose 2 times, then 2 raised power 2, total number of cases 4. If it is repeated 3 times, 2 raised power 3, that means 8 total cases. We can easily find out 2 raised power, put that number